we evaluated the gain of a 2-port, or to one side of the 2-port. To port 1, we connect a signal source which is modeled by a voltage source in series with a resistance, and to the other side we connect a load which is modeled by a load resistance RL. And the expression for the voltage gain we obtained was this one. Okay. So now what we want to do is find out the constraints on Y parameters so that we maximize this gain. Okay. Now Vs and Rs, these constitute the signal source. So we have no control over Rs. Rs is given. We want to maximize the voltage gain regardless of the value of Rs, and RL is the load. So this is also given, and regardless of the value of RL, we would like to maximize the gain. Okay. Now from this expression, let's see. First of all, GS and GL, which are the load conductance and source conductance, they are positive. Okay. And it turns out that
Y11 and Y22 are also
usually positive. It doesn't have to be for a nonlinear 2-port, but we will consider them to be positive. Okay. So in that case, this Y11 adds to the denominator, Y22 adds to a term in the denominator. So to maximize the gain, clearly Y11 has to be 0 and Y22 has to be 0. Okay. Again, so Y11 and Y22 add to terms in the denominator. So to maximize the voltage gain, these two quantities have to be as small as possible, and because we assume them to be positive, we will say that they have to be 0. Okay. This is quite simple to understand. And Y21 appears only in the numerator. So clearly, having as large a value of Y21 as possible will maximize the gain. Okay. So Y21 must be as large as possible. Now the last remaining parameter is Y12. Okay. Now this is a little more subtle. Now first of all, you can see that somehow if you make the product of Y12 and Y21 equal to this whatever you have here, you could even make the denominator 0 and let the gain go to infinity. Okay. Now it turns out that this Y12, what is Y12? It is the effect of V2 on I1, that is the effect of port 2 on port 1. Essentially, within this 2-port network, there is feedback. There is some effect from port 2 to port 1. Okay. Normally, if we think of it as an amplifier, apply an input to port 1 and take the output from port 2. Okay. We don't expect the output to affect the input, but internally there is some effect that is given by this parameter Y12. Now this the effect of this, it turns out, can be quite complicated because it depends on the values of GS and GL and so on. So what you don't want is for this to cancel that and the gain to go to infinity. What does the gain of infinity mean? It means an unstable circuit, a circuit that can produce an output even without an input. Okay. So that's an unstable circuit, and that's certainly something that we don't want. So although it is possible to play with the values of Y12 in order to maximize this expression, that depends on the precise values of GS and GL and so on. So we don't want to even get into that complication. The safest alternative is when Y12 is 0, that is internally there is no feedback. If you apply a signal to port 1, it passes it on to port 2, but if you apply a signal to port 2, nothing comes to port 1. That's the safest one. Okay. So then this disappears completely, and in the denominator you will have only these terms which will be positive. Okay. Y12 equal to 0 to avoid the possibility of the denominator going to 0. Okay. So, broadly these are the constraint on the small signal parameters of the 2 port. Okay. So, from this we have to infer the large signal characteristics of the 2 port. Remember, we have not taken any specific device, any particular amplifying device. We just assume that the device is described with currents as functions of voltages and derived the constraints on the incremental parameters. By the way, you can also use other parameters, that is, if your nonlinear device happens to have voltages described as a function of currents, then you can derive the corresponding small signal parameters, which are Z parameters, and evaluate similar constraints, and you will come to similar conclusions. That is, that the forward parameter, this y21, what is y21? It is the effect of port 1 on port 2, that should be as large as possible, and the feedback parameter y12, that is effect of port 2 on port 1, should be as small as possible. Regardless of the parameter set you choose, it turns out these will be the constraints. Okay. It turns out that most of the real devices are well described by y parameters or with currents as functions of voltages. That is why we chose them. But if tomorrow someone else invents a device which is different, you should still be able to work with them. Okay.